in the college algebra CLEP, the first major topic discussed is actually sets. A set is defined as a collection of objects. And so what I'm going to do is I'm going to give everyone a brief overview of the types of numbers that exist, and then use sets to basically classify and arrange them. So the first type of number that exists is called natural numbers. The second type of number that exists is called whole numbers. The third type of number that exists is called integers. Then we have a category of numbers called rational numbers. And then we have a category called irrational numbers. And we have, now, there's a category that doesn't belong to the real numbers. These are all real. But there's one that is not real, and that, of course, is called, we have complex numbers or imaginary numbers. And just for simplicity, if you don't mind, I'm going to add one more that I personally like. This is just a category or a type of number called prime numbers. So we have prime numbers. Okay, so basically, there are different types of numbers. And we're going to use set notation and a Venn diagram, which, by the way, from my understanding, Venn diagrams actually can be traced back to people like Leonhard Euler. But Leonhard Euler did so many things in math that they gave Venn diagrams to Mr. Venn. But Euler is the one who should own Venn diagrams. Okay, so here's what a Venn diagram looks like. Is where you have like a circle and another circle. So the intersection of the two of them will have the quantity that matches both. So for example, here's what I'm saying. So if you take whole numbers are numbers like 1, 2, 3, 4. And then you take rational numbers like 4 over 1, 5 over 1, anything that can be written as a fraction is a rational number. They share 4, right? That's in the intersection of both of them. But they don't share like 2 over 3. That's a rational number, but it's not a whole number, right? So this will be whole, this will be rational. So in set notation, there's things that you can write called the intersection. Like if we call this a set A and this a set B, you can have A intersection B, you can have A union B. Those are different ways of writing the notation. So that's the first topic that they discuss. It's sort of the union and the intersection of values using Venn diagrams. So your book covers that. I think they do a pretty good job. It's very brief, but I want to encourage you to just go over that quickly and move on. Okay, now I want to draw a diagram that brings together a lot of these. I've talked about this in a lot of my classes. I found it in a Saxon book, an old Saxon book, but again, I'm not tied to one textbook. I generally try to use textbooks to focus on different concepts and see which one explains it well. And this is how they explained it. The first level of numbers is natural numbers. That's the first circle. The examples will be like 1, 2, 3, and that will be like somebody's age. The next category of numbers here is called whole numbers, and that would be 0, 1, 2, 3, and so on and so forth. The next layer above that is called integers, which would include all whole numbers and all natural numbers. So like -3, -2, -1, 0, 1, 2, 3. The next category of numbers above that is called rational numbers. So that would be numbers like 1 over 2, 2 over 3, 4 over 1, -5 over 1. Just remember that everything inside of that would be, again, rational numbers would include everything inside this. Because anything that can be written in the form of A over B would be a rational number. So these are rational numbers. All of these are rational, and rational numbers, of course, is a big category. However, there's another category called irrational numbers. Those are now over here, and those would be like pi, e, the square root of 2, the square root of 3, square root of any prime number, and these are numbers that don't repeat and just go on, right? They're called, some of them are called, we use a word for them, transcendental numbers. But all of these here belong in the same category of real numbers. So these are all real numbers. Outside of this real numbers is where you have imaginary numbers. And that would be the square root of -4, which would be like 2i. And when I is used, the square root of -1, that would be imaginary. So we have real numbers, we have imaginary numbers, we have all these categories here of natural, whole, integers, rational, and then we have irrational, which doesn't, notice that they don't have, there's no intersection between the rational and the irrational in terms of numbers they share. No, they don't share that there, because with rational numbers, it has to terminate or repeat. So like 1 over 3 is actually rational, because it's 0.333 repeating. 2 over 3 is rational. But when you get to pi, 3.14, blah, 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 it just goes on and on, right? We've calculated it to billions of digits and so on. So those are the general categories of numbers. It's important to know that. So we've looked at that. And let me end with number 7. This is very common on the ACT. Prime numbers are numbers that can only be divided by themselves in 1. 1 is not a prime number, nor is it a composite number. 1 is just 1. But 2 is a prime number. That's the lowest prime number. It's the only even prime number. Now I mentioned the word even, so I better define. Even numbers, you have numbers like 2, 4, 6, 8, 10. Odd numbers, 3, 5, 7, and so on. So 2 is the only prime number that is even. The next prime number is 3, and then we go to 5, and 7, and 11, and 13, and 17, and 19, and 23, and 29, and this comes with a lot of practice. You don't need to just know them all. It's just, it's good to know probably the first, maybe the first 15, and we can go into the 30s, and we'll get some prime numbers there as well. We'll go into the 40s, and we actually get quite a bit of prime numbers in the 40s, and then it goes on. Now, what's interesting is there's something called twin primes, and there's a theory that says there's an infinite number of prime numbers. Look up that theory, send me what you think about it, and I'll get you a gift. Okay, we're done. So,
wait, what was the